time parsing and functions. Having the correct date and time format can be crucial when you are constructing your analysis or your reports. You need to make sure you have the correct month, day, and year format to ensure you are using the data from the correct date value. This can be tricky if your data sources are from Excel or from text files, as you can't always control their incoming format. Alteryx has several tools to help us format our date and time columns. The first one we will discuss is the date-time tool. The date-time tool is used to transform date-time data to and from a variety of formats, including both expression-friendly and human-readable formats. You can also specify the language of your date-time data. Let's try to use it in our example here, which has a list of transaction dates and a date of payment that has different date formats. This input is a CSV, so all of the fields are automatically set as a string. Let's add a date-time tool from the Parse tool set and connect it to our input data. The first configuration of the tool is to set the format that you want to convert it to. The first selection is converting a date-time field to a string, while the next one is converting a string field to a date-time format. We're going to select the string to date-time format since our input is a string and we wanted to convert it to a date-time data type. Next, we have a drop-down menu that sets which field needs to be converted to a date time. Let's select date of payment. The next has a text box where we will indicate the new column name of the converted date column. Before adding a field name, make sure that it is different from the first field that we have set so as to avoid duplicates in the column name. Type in payment date _1 in the text box as the new column name. The next configuration is a drop-down where you can specify the date-time language of your incoming string field. Depending on the language, different formats will be available for the options set below. Let's select English as the language. Then we need to specify which of the list format matches our incoming string field, date of payment. Looking at the data stream, our date of payment has 4 digits for years first, separated by a dash, then followed by the month and the date. So from the list, we will select YYYY-MM-DD. YYYY for lowercase y means that the years will be lowercase and composed of 4 digits. Dash is indicated as the separator. MM, 2 uppercase M's mean the months are in 2 digits. And DD, 2 lowercase d's, mean that the day of the month is in 2 digits as well. Once done, run the workflow. In the output, we can see that nothing has changed in the format of the date, but if we added a select tool, we can see that the new column has been set as a date data type. But do take note that Alteryx Designer can't process dates prior to January 1st, 1400. Let's try out the other date column called transaction date. This format cannot be directly converted to a date data type via select tool because Alteryx follows the ISO format. ISO format YYYY-MM-DD HH:MM:SS to represent dates and times. If a date time value is not in this format, the workflow will show warnings that it is not a valid date and will be null on the output. So let's add a new date time tool after the select tool. Select the same format conversion, that is string to date/time format, then select the transaction date as the string field. Type in transaction date _1 as the file name, then set the language to English. The format of the transaction date has date first, separated by a space, then the month and the year. This is not available in the current list, so we have to use a custom format. Selecting custom format enables the text box below that will let you specify your own format of the incoming string field. The Alteryx Designer will then display an example based on the format you enter. So, for the day of the month, we can either put a single lowercase d for digits with no leading 0 or double lowercase d for those with leading zeros. For our example, we are going to use a double lowercase d. Then, next is the separator in between the date specifiers. Here, we are going to use a space. Alteryx also supports other separators such as the backslash, dash, new line, tab, and other characters. Next is our month specifier. We have a 2-digit month with leading zeros, so we're going to use a double uppercase M. Again, type the separator space in between them. Then, for the year, we can either put a double lowercase y for 2-digit year, or use the 4 lowercase y for the full 4-year digit. On our example, we are going to use the 4 lowercase y's. If we have created the format correctly, there will be an equivalent example as seen below. Once we're done with the configurations, we can now run the workflow. You can check the output on the results window and look or filter for nulls. If there are none, then the date-time conversion was successful. Designer also has several functions available for date-time data types. These can help you perform an action or a calculation on any date-time values. First, we have the date-time add. This function adds a specific interval to a date-time value. Add a formula tool to our canvas, then create a new field called add month. Set it as a date data type. On the functions icon, navigate to the date-time category and select date-time add. Here we have 3 parameters to specify in this function. dt for the date-time field we are going to add from, I for the positive or negative integer that will be either subtracted or added to the dt column. This should not have any decimal places, and u for the unit of time that you wanted to add to the dt field. This can either be in years, months, days, hours, minutes, or even seconds. The unit should also be enclosed in quotes. In our expression editor, put the transaction date _1 field as the dt, then type 1 as the integer, and type in months as the unit enclosed in quotes. This will add 1 month or 30 days to our transaction date _1. Run the workflow and check the output. Now we have calculated the 30 days after the transaction date. Here, January 1st, 2019 added with 1 month and became February 1st, 2019, and so on. We can also calculate for the difference between date fields by using the datetime diff function. This function subtracts the second argument from the first and returns it as an integer difference. The duration is returned as a number, not a string, in the specific time units. Let's add a new field called waiting _days with an int16 data type. Then add the datetime diff function. We have 3 parameters to set here: dt1 for the first date field, dt2 for the second date, and u for the unit of time that we will compare dt1 and dt2 with. Same as earlier, this can be in years, months, days, hours, minutes, or even seconds, and should also be enclosed in quotes. For dt1, we will use payment date _1. For dt2, we will replace it with transaction date _1, and then we will set days as the unit. This will calculate the number of days in between the transaction date and date of payment. After running the results, we now have the number of days in between the 2 date fields. We can also insert the date or date time of the day that workflow was run using the datetime now and datetime today function. The difference between the two is that datetime today only returns the date, while the function datetime now returns both the date and the time of the workflow run. Let's add the datetime now function to a field called workflow _datetime. Then type in the datetime now function and set the data type as datetime. Since this function does not need any parameters, we can now run the workflow. The exact date and time value the workflow was run is now appended to our dataset. If we run this workflow again tomorrow, the date will change and be set as October 23rd, 2020. We can also put the first date of the month or the last date of the month by using the date time first of month, open parentheses, close parentheses, and date time last of month, open parentheses, close parentheses function. If you wanted to separate the year and month from your date value so you can separate or group it later on, you can utilize the date time month and date time year function. Let's create two new columns called transaction year and transaction month and set both as a VW string with 25 as the size. On the transaction year's expression editor, add a datetime year function by navigating to the functions icon, select datetime category, and click on datetime year. We only need to specify the DT, which will be the datetime field we will extract the year from. Type in transaction date _1 in the parentheses. Then let's do the same for the transaction month column. Add in the datetime month function, then specify transaction date _1 as the field. Once done, run the workflow. Now we have extracted the year and month of the transaction date column. You can also do the same extract to the date, but using a different unit of time by using the functions date time day, open parentheses, close parentheses, date time hour, open parentheses, close parentheses, date time minutes, open parentheses, close parentheses, and date time seconds, open parentheses, close parentheses. When checking your data format, you might encounter instances where the columns are concatenated to one column. This can be a common sight since not all data available to us is in a clean format and is ready for analysis. In this class, we are going to discuss how to use the text to column tool, which offers an efficient way for us to separate concatenated values. The tool splits the text from one field into either separate rows or columns, wherein each value's separation is indicated by a delimiter. Let's look at how we can configure the text to columns by delimiting this dataset that contains plant ID and plant information concatenated in one column. From the Parse toolset, select Text to Columns and add it to the canvas after the Input tool. The first configuration lets you choose which column to split. From the drop-down, select the Plant field. Then we have the Delimiter text box. Here, you will need to indicate the character or symbol that is used to distinguish individual data values, and where we can split the data. Here in our example, the pipe symbol is used as the delimiter. Let's type in the pipe symbol into the text box. You can also use other characters such as commas, periods, and dashes. Whitespace characters such as tab, space, new line, and space/tab can be used using the following whitespace character keywords as shown in this image. Now we have two radio buttons for the split method. You can either split it to the columns or split to rows. Split to columns will split a single column of data at each instance of the specified delimiter into multiple columns, while split to rows split a single column of data at each instance of the specified delimiter into multiple rows. This method will require a key or ID column so you don't lose track of which value came from which row. Let's try out the split to column first. In this method, we need to configure the number of columns that we will split the text into. In this example, we wanted to generate 3 fields from the plant column since it has the plant name, family, and the scientific name. Indicate the number of columns as 3. Then we have a drop-down where we have to choose the action that Alteryx will take if it finds extra characters left over from the 3 columns that we indicated previously. The options are to leave extra in last column, where data that extends past the split is appended to the value in the column, Drop extra with warning. This drops the extra date and a warning is generated indicating that there was excess information. Drop extra without warning, where data that extends past the split is dropped and no warning is generated. And finally, error, where data that extends past the split causes an error and the workflow stops processing. Let's select Leave Extra in last column so we do not lose any data. Then we have the Output Root Name text box where we need to enter the name for the new columns to be generated. The columns will have this root name plus an integer in the field name. In our example, since we have the root name plant, our generated fields will have the names plant 1, plant 2, and plant 3. There are also advanced options we can set on the last part of our configuration window. The Ignore delimiter in quotes, single quotes, parentheses, and brackets will ignore the delimiter symbol if it has been enclosed in any of the mentioned symbols, meaning it will be retained as a value instead of marking it as a separator. The last option is to skip empty columns. This will disregard the lines that has an empty value and will treat the next string as the correct value for that placement. Let's run the workflow to see if we need to add any advanced options to our data set. Our first and fourth record has null values on the plant 2 field and the data was pushed into plant 3. Referencing from the original concatenated plant column, we can see that there are extra pipe delimiters in between value 1 and value 2. So let's enable the skip empty columns and then rerun the workflow. Now that we have it enabled, it has ignored those extra delimiters in between, and they have aligned the second value properly. Now let's try the split to rows method. Instead of creating new columns, this will create new rows for each value. Add a new text to column tool below the first one and connect it to our input data. Set the same column plant to be split and pipe as the delimiter. Then click on the Split to Rows radio button to set the method and enable the Skip Empty Columns. Once done, run the workflow. From the results, we can see that each value has been separated using the delimiter, but it has been added as a new column. This is why the record ID is essential, so as to reference which line belongs to which record. We can also use this method of splitting to rows first if we are not sure how many columns or values our data has. We only need to add a Summarize tool after it. On the new Summarize tool, select the record ID, in this case the plant ID, then set action to Group By. After that, select the field we split, in this example our plant field, and set its action to Count. Then run the workflow. Now we have the number of data values for each record ID. We can now set the split to columns into 3 since they all have the same amount of value. Now that we have separated the data, we can rename the generated fields in a Select tool. But another nifty way of applying a rename is via the Dynamic Rename tool of the developer's tool set. The Dynamic Rename tool renames columns within an input data stream. You can use this tool to parse text files, to pull column names from the first row of data or a description file, or to rename a pattern in the column names, such as removing a prefix or suffix, or replacing underscores with spaces. This time we are going to use this tool to take the headers from this text input and make this the new field name of our plant dataset. Make sure that the fields align first. On a Select tool, deselect the plant field that contains the concatenated text. What's left is the 4 field names from the left, and that is the same for the right text input, which has the correct 4 field names. Now, let's reconfigure the Dynamic Rename tool. On the Rename method, select Take Field Names from Right Input Metadata. In this method, selected columns are renamed using the field names from a second input connected to the R anchor. Only the field names from the second input are brought in. The data does not come through. You can also use this tool to get field names from formula, to add prefix suffix on the field name, and to take field descriptions. Once we've set the rename method, We can now adjust the report behavior if the field names from the left did not match the right input. You can either set it to warn, error, or ignore. If you wanted to follow the data type and size from the right input, you can enable the last configuration, change field type and size. Once done, run the workflow. Now we have applied the correct field names from our delimited data set. Most analysts and data enthusiasts who are regularly using Excel files are familiar with the VLOOKUP function of Excel. VLOOKUP, or vertical lookup, is a function that lets you search for data in a table that is organized vertically. This is usually used to append a value from the source into a currently used table. Alteryx has a similar tool to the VLOOKUP function. This is the Find Replace tool from the Join tool set. The Find Replace tool searches for the data in one field from one data stream, which can either replace or append a specified field from a separate data stream. Drag a Find and Replace tool from the Join tool set and put it in the canvas. The tool has two input anchors. F anchor stands for Find. This will be the table or data that you want to update with the results. Let's connect our company name and addresses input into the F anchor. R anchor, which stands for Replace, this will be the input or the source table that contains the data that you wanted to replace or append to the original input. We will connect our abbreviations input to the R anchor. What we wanted to do is change the common address words from the street address into an acronym provided by this second sheet. The second input data is from the second sheet of our Excel file. It contains the common address names and abbreviations or acronyms. In this tutorial, we are going to replace the long common street words into their abbreviations. For example, our first line has the address 71774 Hopker Parkway. We wanted to change the word Parkway into PKWY, as indicated by our second sheet. So every instance of the word park that's in the address column would be abbreviated to PKWY. Let's go over the first part of the configuration. The upper left side is composed of 3 radio buttons which let you choose the part of the field that contains the value we need to find. We can either look for the word at the beginning of the field, any part of the field, or the entire field. Set it as beginning of the field if the field is from the start of the string. For example, if you are looking for street numbers, you can find it at the beginning of this street address. Any part of the field will look for the word/character anywhere. It can be from the start, the middle, or the end part of the string. This will be the method we will use for our example, since we wanted to look for each instance of street common names in any part of the street address string. Lastly is the option for entire field. This will make the find and replace method similar to that of the join tool. It will look for the exact word value in its entirety of the column, meaning those that contain the words but is not an exact copy of it will not be matched to the data value. Let's set the radio button to any part of field. Now we have to set the Find Within field. This should be the field where we wanted to match or find the data values in. In this case, we're going to select Street Address. Then we have to set the Find Value field. This should be the field from the reference table or the data source we have connected to the R anchor. In this example, we are setting it to Common Name. This means that we wanted to find the common name anywhere in the street address. Next, we have 2 optional parameters. Enable Case Insensitive Find if you wanted to match for words regardless if they have different letter case, and enable the Match Whole Word Only if you wanted to search for the whole words, meaning it has white space before and after the value. For this example, we will enable both Case Insensitive Find and Match Whole Word Only since we are using common names. The last part of the configuration is to choose how the data values that have matches found will be put into the current data stream. Here we have two options, either replace found text within the value or append the fields to record. Choose replace found text within the value to update the original column with the new data from the specified field. This will replace the common names found within street address by the address acronym. Optionally, we can also enable replace multiple found items if we wanted to replace multiple strings in each cell. But this function should only be enabled if we have used the any part of the field method. Choose append field to record if you want to attach any column from the reference table into the current data stream. You can select which fields to append by selecting and deselecting them on the list. Let's try the replace function first. Set the as field address acronyms, then run the workflow. The parkway has been shortened to PKWY, same as the lane, which has become LN, and so on. Those that did not find a match, such as the word park, will retain their original value. Let's configure the tool to append and see how it differs in output. In the configuration window, select Append Field to Record, then choose the common name to append it to. Once done, run the workflow. In the output window at the far right of our dataset, the two columns that we specified have been appended. The lines with null value mean that those records do not have any match upon looking at the value/words on its street address. Thus, it did not have any matching acronym nor common name. The Find and Replace tool can also work like a join tool in terms of exactly matching the values. Let's test it out on the same dataset, but using a different reference table. This has a list of states, abbreviation, and their name. The goal of this example is to append the long state name to the current company data stream using the match values in state code or abbreviation. On a new Find and Replace tool, set it to Find Entire Field. Then set Find within Field to State with Find value as state abbreviation. For the Replace part, we will set it to Append Field to Record. Then append the state name, then run the workflow. Now we have appended the long state name to the data stream based on the exact value match of their state code. You can always add a filter after the Replace tool to check if it has null values or unmatched records. The difference of the Find and Replace tool to that of the Join tool is their flexibility of function. Find and Replace has the functionality to search on any parts of the string, while the Join can only match by exact character-to-character values. Next is their runtime. A Find and Replace tool might take a lot longer since you are looking at a match for each word or characters of every record, while the Join tool is a straightforward process of matching value by value. Third is their output anchor. The Find and Replace tool has only one output anchor, so you have to filter out if there are some nulls if you're going to append a function, while the Join tool has an output for the left/right data that do not join and the join matches. Fourth is their reference match. If there is a duplicate value from the reference table, the Find and Replace tool will use the first unique value and disregard the duplicate, while the Join tool will output all matches including the duplicate. If you only want to append the data and not match it by value nor by row, you can utilize the Appends Fields tool. This tool performs like a Cartesian join, wherein every record from the source is joined to every record in the target data stream, meaning if we have 5 records on the source and 1,000 records on the target data stream, this results in 5,000 records. Let's see this tool in action on the same dataset we used earlier. This time, we will append 2 records containing the year 2019 and 2020 to each row of our company dataset. Click on the tool Join Set and drag an append field into the canvas. This tool has 2 input anchors like the Find and Replace tool, T anchor for the target data stream and the S anchor for the source or the smaller data stream, which will have the records to be appended. Connect the company dataset to the T anchor and the text input into the S anchor. The configuration window of the append looks the same as that of the select tool, but this also has an input indication as to where the listed field came from. Same with the select tool. You can rename, deselect, and change the data type of the fields. Aside from the window, we can also set the message to show if it's generating too many records. You can set it to either allow all appends, all records will be appended to all records with no error or warning, warn on appends or more than 16 records. If more than 16 records are in the source file, S input, a warning is reported and the workflow continues processing. Error on appends of more than 16 records. If more than 16 records are in the source file, S input, an error is reported and the workflow stops processing. We will set it as allow all appends since we wanted the year 2019 and 2020 to be attached to each record, and we will not make any further changes in its embedded select window. Upon running the workflow, we can observe from the connection progress that 2 records were taken from the source, 100 records from the target field, and it has an output of 200 records. In the output window, we now have a 2019 and a 2020 value appended for each record of the target company dataset. In an earlier topic, we discussed the use of the Formula tool, which helped us efficiently create multiple functions to several fields in just one tool. But what if we just wanted to apply the same function to several columns or fields? Do we have to create multiple copy-paste functions for the rest of our configuration? There is no need for that, as we have the Multifield Formula tool. This tool is used to create or update multiple fields using a single expression. The downside to it is that you can only use one function or expression per tool. If you wanted to apply 2 or more expressions using the Multiple Field tool, you need to add a new tool for each. Let's try this tool out on a workflow where we are preparing the categorized supermarket sales that will be used in a clustering model. Here, we want to replace all the null values with a 0 so that our later analysis won't encounter error messages when it's running. Drag a Multifield Formula tool from the Preparation tool set into the canvas and connect it to the Input Data tool. The first part of the configuration window has the list of fields available from the input data that we connected it to. You can minimize this list by selecting the specific data type that you wanted to work with. In this example, all of our field is in the double data type, which is a numeric. In the list, select fresh, milk, grocery, frozen, detergents, paper, and delicatessen as the fields that we are going to work with. You can also choose to include the dynamic or unknown fields to take in new fields that will be added in the future. We also have 2 optional settings on how we want to show our output. Enable the copy output fields and add if you wanted to put the output of your expression into new columns. This also has the option to add a prefix or a suffix in your data. Let's disable or uncheck this one because we only wanted to update our current fields. You can also change the data type and size of the output columns by enabling the Change Output Type to. Let's keep this unchecked and proceed with our expression. Here we have 3 tabs and 1 expression box. The first tab contains the list of variables. This is similar to the variables and constants icon on the Formula tool. It contains the list of current field, original fields, and constants. Click on the plus icon of the current field. This will be the variables we will be working with when we are applying an expression to multiple fields. Current field is for using the selected fields for the function. Current field name is for using the file name in the function. Current field type is for using the data type of the selected fields in the function. The Functions tab, same with the Formula tab, has the list of functions grouped by category. And the final tab contains the recent or saved expression that we have in Designer. You can also save and load your current expression on this tab. Since we wanted to replace nulls only, we will be using a conditional if-then-else function. On the Functions tab, select the If-Then-Else function. Our C, or condition, will be to check if the current field is null, so we will use the isNull function from the test functions. Click on the isNull function to add it to the expressions editor. Then replace V with _current_field_ from the Variables tab. Replace the T with 0 and replace the F with _current_field_. This means that every time we find a null value on any of the fields or values, we will replace the value with 0. But if it has a value, the original value will be retained. After running the workflow, we now have replaced the nulls into zeros throughout the 6 fields. Another tool that has a similar capability is the Multirow Formula tool. This tool can help us reference and compare rows using the different formula functions. It is different from the regular formula tool, and the Multifield Formula is on which record it works on. Rather than comparing and processing columns by columns, this tool uses row by row. To further explain its usage, let's use the tool on this dataset that has a list of players' login dates and their active time while being online. What we wanted to see in our output is the number of days between each of the players' login. So for this process, we need to compare the dates between each line and get their difference. Drag a multi-row formula from the preparation tools set into the canvas and connect it to the select tool. The first configuration of the tool lets us choose whether we wanted to update our existing field or create a new one. Let's create a new field and name it as days between login. Then set the type to an INT32. The numRows configuration lets us set the number of row variables that we will use for our expression. Set it to a 1 if you are going to compare row 1 to one row below or above it, or set it to a 2 if you wanted to compare every other row, and so on. We are going to set it to a 1 since we are going to compare each date per line. Next, we have an optional configuration of setting a group by a specific field. Our dataset has the player information, and we need each date computation separated by player, so we are going to group this by player ID. For those instances wherein the date for each player ends and can't compare it to the next one, since it's either the end of the data for that player or it did not precede any rows above it, we can set those values by the Values for Row That Don't Exist drop-down menu. We're going to set the value to null. Next, we have the same 3 tabs that were also available in the Multifield Formula tool earlier. The only thing that differs is variables, which now have the row +1 and -1 for row comparison. For our output, we wanted to get the days between each row, so we are going to use the DataTimeDiff function. Add the DataTimeDiff function by selecting the DateTime category of the Functions tab and selecting DateTimeDiff. Before we set the parameters of this expression, it is important to ensure that our data is sorted properly. Add a Select tool, then configure it to Player ID in order of ascending, and the login date in ascending order as the second level. This is done to ensure that the rows with the same player ID are grouped together, and we have the dates of login from the last dates to the earliest date so as to compute the date difference properly. Back to the multi-row configuration. Set the DT1 into row +1, login date, and DT2 into row +0, or active rows login date. Then set U, or the units of difference, into days. This will compute the days of difference between the date of line 2 minus the date of line 1 and put the value on the days between login column. Run the workflow to check the output. Looking at the output, we now have the difference between each date by player ID. The difference between May 1st, 2020 and May 6th, 2020 is obviously 5 days, which has been saved into row 1's new column. Same with the difference between May 1st and June 3rd, which is saved in row 2, and so on and so on. We can also see the null values that we indicated in Values for Row That Don't Exist earlier. The data stopped because there is a different player ID on the next line. We can also use this tool to populate missing values in our dataset. In this text input, we have the year, quarter, and sales for these three titles separated by quarter. The problem is that the year is not populated throughout and was only indicated on the first line every quarter, 1. Let's use the Multirow formula to populate the null values by filling down the year. On a new Multirow Formula tool, set it to Update Existing Field. Make sure that the field, year, is also selected on the drop-down, since this is the field we need to fill. Set the num rows to 1, since we are still comparing each line, and the values for rows that don't exist to 0 or empty. We will not use any groupings this time. On the expressions editor, add the if then else function. Replace C with is null, open parentheses year, close parentheses, then replace T with row -1, colon, year, and finally replace F with active row year. This will test if the current row you're looking at is null or not. If it's null, it will populate it by using the earlier row. If it has a value, it will retain that value. This means that every time the tool processes a line, it checks if it has a null value. If it has a value, it will leave it as it is, but if it is a null, it will take the value of the earlier row and replace that null value. This will be done for each cell of the specified column until it reaches the last record of the dataset. Run the workflow to check if we have correct output. As expected, we have populated the rest of the null values with the correct year values. Let's look at an example of how we can integrate the past tools we have discussed into one workflow. The dataset we are going to use is a list of movies with the rating, director, and actor listed in a separate file. What we wanted for our output is to have the data from all of the datasets together in one data stream and clean them as well. As the first step, let's check on our 4 datasets first. According to the metadata on the results window, our fields are all in V-string in the same size. Going back to our Data tab, we can see a small yellow line on the data quality bar of all the fields, which indicates that it has null rows. We can also see a red bar on the movie title that indicates that some of its lines have white spaces. We also have 3 ID fields in the file: Movie ID, Director ID, and Actor ID. We will use these IDs later to join our datasets together. Let's combine the movie title fields and the ratings first. Add a Join tool to the canvas from the Join toolset. Connect the movie's title into the left input actor, while the ratings will be on the right. Configure the Join tool to join by specific field, since we have IDs on both datasets. Then, set the left field to Movie ID and the right Join field to Title ID. On the Embedded Select window, let's select the Title ID field, then run the workflow. The connection progress shows us that we have joined 46 records on the J output anchor. But there were also 10 records on the left output anchor that were not matched by Movie ID. This means that the ratings for these movies are not available on the ratings file. Look at the L output anchor. We have 6 rows that are null and 4 that have data. We wanted to put those 4 rows back into our data stream and disregard the nulls. What we need to do is add a filter tool, connect it to the left anchor, then configure it as a basic filter wherein Movie ID is not null. Run the workflow to check our progress. We have now successfully removed the null rows, so let's mark this data since its ratings are not available. This will make a future QA easier if we are looking at missing outputs. On a new Formula tool, add a column called Rating, then set it as a data type VW string that's 255 in size. For its value, set it as the text not available enclosed in quotes. Now that we have it marked, let's add a union tool to put this data back to our current data stream. Connect the output anchor of the Formula tool into the input of the union tool. Do the same for the J anchor. You can check if the fields are aligned by looking at the Manually Configure Fields output columns list. Let's run the workflow again to see if we have done it correctly. In the output window, looking at the far right of the dataset, we now have the rating, where the lines that did not join earlier have been included with the mark Not Available. Now let's connect the director names to the dataset. There is only one director ID per line, so we can use the Join tool to match it by director ID. On a new Join tool, connect the output anchor of the Union tool into the left input anchor of the Join tool. Then, connect the director input data to the right input anchor. Once done, configure it to join by specific fields using the director ID column. As we can see on the embedded select window, there is a duplicate field on the output. We can remove it by clicking on Options, then click on Deselect Duplicate Fields, then push the field director name to the bottom of the director ID on the list by selecting the field, then clicking the arrow up 4 times. Once that is done, run the workflow again. We now have 3 of our datasets available. Let's add the final one. The actor ID of the dataset has been concatenated per movie. So this time we can't rely on the Join tool, but instead we're using the Find and Replace tool. Drag a Find and Replace tool into the canvas. The left input anchor will be from the J output anchor of the earlier Join tool, while the right input will be from the actor's dataset. We will now configure the tool to look for any instance of the actor's ID and replace them with the specific actor name. To do so, set the Find method to any part of field, set the Find within field to actor's ID, then set the Find value to actor ID of the right input. Then, for the Replace, choose Replace Found Text with Value. Then set this to actor name. Enable the Replace Multiple Found Items. Run the workflow if you are done. Looking at the actor's ID field, we now have replaced the ID with the value of each actor's name. Since we are using the full name for the directors and actors, let's ensure that these fields are in the correct title case. Add a Multifield Formula into the canvas. Then connect the output of the Find Replace tool to the input of the Multifield. In configuring the tool, select the field Director Name and Actor's ID on the list. Since we are just updating the field, you do not need to enable the Copy Output Fields and Change Output Type. Then, on the Expression Editor, let's add the function. From the Functions tab, under the Strings category, select Title Case. In this function, indicate the string to be the variable _current_field_. This will process both our director name and actor's ID into the title case format. Then let's convert our Date Published field to the proper date type and format by using the DateTime tool. Add the tool to the canvas and put it after the Multifield Formula. In the configuration, set the conversion format to string to date/time format. Then set the string field Date Published as the field to be converted. Its new column name will be Screening Date. Once we have that selected, specify English as the language. Our Date Published string date has the format days, then months, and year, all separated by a period. We will use a custom format since it is not available in our list. Select Custom on the Format list. Then, on the text box, type %symbol followed by lowercase d, then put the separator period. Then, %symbol again followed by smaller case m. Another separator period, then %uppercase y. This specifier format means that the days are in 2 digits, same with the month, and the year in full 4 digits. The separators are indicated in between. You can check if you have created the correct format by looking at the example below. The example should match the format that you have indicated, while the output will be in the Designer ISO date format of year-month-day. We still have an unformatted field in our dataset, which is the movie title. We will need to trim some of its white space, as indicated by the red triangle above the cells that has white space. To do so, add a Formula tool to the canvas. Set the column as Movie Title, Then, on the expression editor, add the trim function. Specify the string to be cleansed as movie title. Then run the workflow to check our progress. Now we have no white space left, as proven by our data quality indicator bar, which is now all in green. Looking at the output data anchor, we still have a concatenated field that is left in our dataset, specifically the actor's ID. Since we are not sure of how many actors there are for our dataset, let's count the values first. Add a text to columns tool to the canvas and connect it to the formula tool. Set the column to split into actor's ID with the symbol comma as the delimiter. Then set it as split to rows and enable skip empty columns. This will split actor's ID into rows. Once done, let's add the summarize tool so we can count how many rows it is split into for each movie. Put the summarize tool after the text to columns used earlier. Then select movie ID and set its action to group by. After that, select actor's ID and set its action to count distinct non-null. This will give us an output of movie ID and the count of actor ID that it has. But we still need to get the maximum count from this list. To do so, add a new summarize tool, then using the count distinct underscore actors ID field, set the action to max and run the workflow. We now have the maximum number of actors available in our dataset. Let's use this information to split our original data stream to 4 actor columns. In a new text to columns tool, set the column actor IDs and the delimiter comma symbol. Now let's select split to columns with 4 as the number of columns. Let's leave extra characters in the last column and use the word actors as the output root name. Once done, run the workflow. Since we have completed our cleansing and blending process, we can now remove the extra columns that we don't need anymore. In a select tool, deselect the director's ID, actor's ID, and date published. Then move the actors 1 to actors 4 below the director name. Once done, we can now save this output to our desired path and format via the output data tool. Gaining more knowledge about the tools in Designer can help you effectively automate most of your manual processes. In doing so, your workflow expands and becomes more sophisticated as the process gets more complicated, thus making it more difficult for you to backtrack your progress or even check errors in the farthest end of the line. In this session, we will talk about some of the tips you can use to make your workflow comprehensible and easier on the eyes. Tip number 1, prep your canvas. The canvas is the main thing we are looking at when working on Designer. We can customize this orientation and settings by navigating to Options, User Settings, Edit User Settings, Canvas. The orientation of the workflow is on the Layout default, where we can set it to either horizontal or a vertical layout. Horizontal lets you work from left to right, while the vertical one lets you work from top to bottom. We recommend using verticals if you are used to using the scroll buttons to navigate. You can also change the color of your canvas or add a grid to make it easier for you to align your tools. It has a snap to grid option to make drag and dropping tools much easier. The canvas settings also let you choose the type and color of your connection lines. Under connection settings, you can choose from Auto Route Bezier, which is the curvy connection line and automatically curves to the point and swerves away from tools, Auto Route Perpendicular, which is a pointer version of the Bezier, and Straight, that is true to its name, simply a straight line. Unlike the Auto Route lines earlier, it does not swerve around lines and tools. Lastly, you can show or hide the progress or the small annotations that have the number of records, percentage, and record memory size. This can be useful if you are checking some duplicates or if you are blending data from various data streams. Tip number 2. Keep your favorites close. In our tool set, you can see that the first tab is called Favorites. This tab is always positioned on the first tab and contains the tools that we frequently use for our workflows and processes. To add a tool to your favorites, hover over the tool and you will see a star icon on its upper right. Click on it and it will be added to the Favorites toolbar. Aside from the Favorites toolbar, you can also pin a specific tool set to the front of the tool palette. Right-click on the tab of the tool set you wanted to pin, then select the Pin plus tool set name. This tool set will then be moved beside the Favorites toolbar. Tip number 3. Alteryx Sticky Notes. Having the proper documentation is extremely important. Capturing your logic and taking notes of important steps in the Alteryx Designer is quick and easy with the use of the Comment tool. The Comment tool is under the Documentation tool set. This lets you add notes and images to your workflow to make it easier for you to explain your processes. In the Documentation tool set, select the Comment tool and add it to your workflow. You can double-click on the comment box and type your notes directly, or you can also type it in the configuration window's text box. You can also personalize the shape, color, and font that you want for your comments. If an image is needed, you can load your own image by clicking on the folder icon and selecting the image file on your PC. This image will then resize according to the size of your comment box. Drag on its edges to adjust the size of the comment, and you can also hold and drag it to other parts of your workflow. But if you're adding comments for each tool, it is better to use the annotations. Annotations are the small rectangles seen below each tool if you have set the Canvas Options annotation to show. They also move together with the tool, unlike the comments. To add one to your tool, click on the tool and select the Annotations icon. Type the text you want to add. Then choose a setting on the drop-down on how you wanted this annotation to show up. Using Canvas settings will depend on the Canvas options you have set. Always will show the annotation regardless of Canvas setting, and never will not show the annotation on the canvas. You also have the option to show it above the tool instead of on the bottom of the tool. You can also add comment strings to your expression editors by adding a double / before your single line of comment. Comment strings are useful for marking and taking note of the logic used for that expression. If you wanted to add a block of comment string, enclose it in a / asterisk and an * in the end. This can be done for any expressions editor like those in the Filter tool, Formula tool, Multifield, and many others. Number 4. Organize like Marie Kondo. Clutter is caused by a failure to return things to where they belong. Alteryx helps us channel our inner Marie Kondo by using the tool Container. This tool helps us organize or isolate a section of our workflow. To use the tool, drag a tool container from the Documentation tool set into the canvas. Then we can select or highlight the tools you need to group and drag them inside the rectangular area of the tool container. Now you have them separated from the rest. These tools will still be processed if the container is open. You can disable them by checking the Disable checkbox of the configuration window, or click on the blue button on the upper left part of the tool container itself. It's blue if it's open and white if it's disabled. Having it disabled will hide the tools and stop them from processing the data in that stream. You can also change the tool container's caption to make it more informative by replacing this name on the text box or double-click on the name. You also have the option to change its text color, fill color, border color, transparency, and margin. Tip number 5. Decluttering wires. Having 100 tools can also mean having 100 connection wires. If a couple of connections are blocking your view, you can make them wireless by clicking on the line itself and enable the wireless function. The anchors with this symbol mean they have wireless connections. What if you have multiple connections connected to a tool and realize that you need something in between? You do not have to delete every wire, only to reconnect them again to the inserted tool. Just right-click on the tool, then select Insert After, and select the tool to insert. The rest of the outgoing connections will be connected to this new tool. But what if it is the other way around? If we wanted to get rid of an extra tool in between, right-click on the tool, select Delete, and connect around. Tip number 6, align and distribute. It can be hard to align your tools at times, even when you are using the grid view. Good thing we have an auto-align function in Designer. Just highlight your tools, then right-click and choose either Align Horizontally for horizontal canvas or Align Vertically for vertical canvas orientation. You can do the same by pressing the shortcut keys Control and Shift and dash symbol to highlight horizontally, and Control and Shift and plus symbol to align vertically. Tip number 7. Shortcuts makes your work fast. Alteryx has several hotkeys that can help you design your workflows efficiently. Here are some of our favorites. If you have several tabs of a workflow opened, you can move between each tab by pressing Control and Tab. This will show a small window that has the workflow name and a small canvas preview. If you wanted to save all of those open workflows, press Control and Shift and S. The usual shortcuts for undo, redo, copy, cut, and paste also works for the tools in our workflow. Press Control and F to show the Find menu. This can be helpful if you are looking for a specific tool or function in your canvas. To pan your canvas without using the scroll buttons, hold your mouse center/scroll button, then the pointer will change to this symbol, and you can now pan the canvas as long as you hold the center button. You can also zoom in on one part or another by pressing Control and scrolling up and down. If you wanted to refresh your workflow when the incoming data file has been changed externally, press F5.